The topic for Lesson 2.2 is logic. You'll determine truth values of conjunctions and disjunctions and construct truth tables. When you answer true-false questions on a test, you are using a basic principle of logic. For example, refer to the map and answer true or false. Raleigh is a city in North Carolina. You know there is only one correct answer. It is either true or false. A statement, like the true-false example above, is any sentence that is either true or false, but not both. Unlike a conjecture, we know that a statement is either true or false. The truth or falsity of a statement is called its truth value. Statements are often represented using a letter such as P or Q. The statement above can be represented by P. Raleigh is a city in North Carolina. We know the statement is true. The negation of a statement has the opposite meaning as well as an opposite truth value. For example, the negation of the statement above is not P. Raleigh is not a city in North Carolina. In this case, the statement is false. If a statement is represented by P, the not P is the negation of the statement. And symbolically, they put a little tilde there, and it's read not P. Two or more statements can be joined to form a compound statement. Consider the following two statements. P. Raleigh is a city in North Carolina. Q. Raleigh is the capital of North Carolina. The two statements can be joined by the word and. So P and Q could be read, Raleigh is a city in North Carolina, and Raleigh is the capital of North Carolina. The statement joining P and Q is an example of a conjunction. A conjunction is a compound statement formed by writing two or more statements with the word and. And symbolically, they write that P and Q. It looks like an A that they just didn't cross to me. A conjunction is true only when both statements in it are true. Since it is true that Raleigh is in North Carolina and it is the capital, the conjunction is also true. Use the following statements to write a compound statement for the conjunction P and Q, then find its truth value. Okay, they gave us sentences for P, Q, and R, and that's kind of how they'll do it in the book because they're going to give us several things to do with this set of information. 1 foot is 14 inches. No, it's 12. And September has 30 days. Yes, it does. So I would write this symbolically, false and true. And because we have one false, the whole statement is false. The only way a statement can be true with an and is if they are both true. Now, a plane is defined by 3 non-collinear points. That's true. But still, true and P is still false. So true and false still gives us a false. We can't have any falseness in an and. So now they want us to do not Q. So if Q is true, then not Q would be false. So not Q and true is still false. So the compound statement we'd have to write out in words, September does not have 30 days, and a plane is defined by 3 non-collinear points. So it is going to be false. This time they want to change it to not P, so not P would be true. That's good. So we're going to add for the not, 1 foot is not 14 inches. The sentence you'll have to write out is, a foot is not 14 inches, and a plane is defined by 3 non-collinear points. So this time we've got true and true finally equals true. We have one statement that is true out of the 4. Now on this one, we negated a false statement and it made it true. The negation of a statement is not necessarily false. It just has the opposite truth value of the original statement. Statements can also be joined by the word or. This type of statement is a disjunction. Consider the following statements. Ahmed studies chemistry, Ahmed studies literature. So P or Q would be written, Ahmed studies chemistry or he studies literature. A disjunction is a compound statement formed by joining two or more statements with the word or. So this one, I kind of imagine it could be like a little teeter-totter. It can sway either way. So that is read P or Q. A disjunction is true if at least one of the statements is true. In the case of P or Q above, the disjunction is true if Ahmed either studies chemistry or literature or both. The disjunction is false only if Ahmed studies neither chemistry nor literature. Use the following statements to write a compound statement for the disjunction P or Q and find its true value. So we're just going to write those out. Segment AB is a proper notation for line AB, or centimeters are metric units. Well, as I read this, you could tell this one was false, and obviously this one is true. But for an or statement, we only need one that is true. So false or true, it's okay because we have one that's true, it's going to be true. This time they want us to do Q or R. Okay, we said that Q was true, R is false. So first we'd have to write it out in words. Centimeters are metric units, or 9 is a prime number. Then our answer, we had true or false, is going to be true because we can have one false as long as we have one true and still get a true result. So the only way an or statement can be false is if we have one that is false or false. It's the only way to get a false. Venn diagrams are a nice way to illustrate truth value. The Venn diagram shows the number of students enrolled in Monique's dance school for tap, jazz, and ballet classes. How many students are enrolled in all three classes? Well, looks like the very middle where they all overlap is 9. And we should label them students. How many students are enrolled in tap or ballet? Okay, so ballet encompasses this whole thing, and then we need to add the 28 and 13 that are not in that circle. So there's only 43 that are just in jazz. And when we add them all up, we get 121 students. How many enrolled in jazz and ballet but not tap? Again, okay, look at the diagram. We need jazz and ballet but not tap. Oops. Okay, so that's only going to leave that little green overlap is 25 students. The last topic we need to look at is truth tables. A convenient method for organizing the truth values of statements is to use a truth table. If P is a true statement, then not P is a false statement. If P is a false statement, then not P is a true statement. Truth tables can also be used to determine the truth values of compound statements. So again, kind of like we've been talking about, the only way we can get a true is if they are both true, and the only way we can get a false on an or is if they are both false. They asked us to construct a truth table for not P or Q. So the order of P and Q for checking, we're going to use the same order every time, so it makes it easier to check the last column. We're always going to let the P's go true, true, false, false, and Q go true, false, true, false. It just makes it easier to check. Now we can fill in not P. So the opposite of true is false, and the opposite of false is true. Now when we're ready to go not P or Q, Okay, I need to ignore that first column. I'm just comparing those last two now. So on an or statement, the only way they're going to be false is if they are both false, and then that means the rest of our statements have to be true. This used to be a really big topic in geometry. We're going to look at another one, see if we're getting the hang of it. It's growing. Now we have values for P, Q, and R. So again, I'm going to give you the values for those three columns because then our answers will line up nicer. So now when we go to fill in not Q, every time there's a true, it's going to be false. Every false is now true. And now we want to compare not Q to the column right next to it, R. So an and is only true if they are both true. I think that's the only two. Then everything else is going to be false. So it's got some falseness to it. Okay, now we need to compare the first column. I'm going to mark out the two that we don't need here. Oh, and actually we don't need that one anymore now either. Okay, so we're just comparing the first column with the last column we just filled in, and we want it to be an or. So an or is only false if they are both false. So I'm looking for false falses. There's a false false, and false false, false false. That means everything else has a true in it somewhere, and we are done. One more truth table. Hopefully it's coming. Okay, they want a truth table for P or Q and not R. We have the exact same values for P, Q, and R we did on the last one. I'm just going to fill in my not R, so every true becomes a false, and every false becomes a true. And now we want P or Q. Okay, that's only going to be false if we have false, false. I think that's the only false, false I see. So that means the rest of them have to be true. Oh, there's another false, false, missed one. Okay, so now we want to compare the one we just did, P or Q, with the not R. Okay, that's not too bad, because now we're just looking at our two pink columns that are right next to each other. That's handy. And this is an and. So the only time an and is true is if they are both true. And those are the only ones. So the rest of these are going to be falses. And that's our truth table. The negation of a statement has the opposite truth value of the original statement. Venn diagrams and truth tables can be used to determine the truth values of statements.